be looking for you to make a decision by tomorrow.
No.
But yeah, I think you want to get him.
Well, on it, yeah.
Yeah.
You know, like,
let him know you're working on it, and you expect it to respond in a certain amount of time.
Yeah.
Okay.
So yeah.
So that's good. So I appreciate everyone. Anything else?
No.
Yep. Okay. So I appreciate everyone's mentioning that. So I want to use remaining time to talk about sort of the second part of this dimensional analysis discussion that we had a few times ago. So does anyone remember? Give me the gist. So we went over some material as part of that discussion. What was the gist of units and dimensions? What are they basically? Do you remember that? We had a little presentation on it. Does anyone recall? Why are they useful? So what's the difference between a unit and a dimension? Does anyone remember that?
Well, the unit's a measuring stick.
Yes. The unit has a yardstick associated with it.
And there's various units to dimensions.
Much like this one.
Yeah,
that's right. There's multiple units that can be associated with a dimension. So give me an example of a dimension.
Length.
Oh, thank you. A length. So length is a dimension. And give me some yardsticks associated with it.
You've got 3 in your hand right there.
Okay.
Centimeters, inches, feet.
Meters, yeah.
Yeah.
These are all different ways of measuring length, right? And it doesn't make sense, we said, to add a foot, to add 1 representing 1 foot on the one hand, to a 1 representing 1 meter on the other, and say we have 2. Well, 2 of what? It doesn't make sense. It's semantically nonsensical. In order to do that, what do we have to do? If I had 1 foot and 1, to simplify it, 1 yard. People here know what a yard is?
Yeah.
Okay.
Football's in yards, man.
That's true. Is Canadian football in Canadian yards?
Is there a difference between a U.S. yard and a Canadian yard?
I'm teasing you.
Is it supposed to be a U.S. thing, where Canada uses meters?
No.
Yeah. In the U.S.
We use yards normally here.
Yeah.
Really?
Well, yeah, yards on the football field. Yeah.
Okay.
We just have wider fields. You guys.
I see.
Big balls.
I wouldn't know. But I'll leave that. Okay, so
a delicious pun.
Yeah. Yardsticks can be used for many things. Okay, so if I had one foot in 1 yard, what would I have to do to add them?
You'd have to change one to the other.
Yeah.
Right. So I could convert 1 yard into 3 feet, and then I could add it to the 1 foot, and we get 4 feet. Right? 1 plus. You can't just say 1 plus 1 is 2. If they're in different units, it doesn't make sense. Now, if they're in different dimensions, it's even more nonsensical. I want to add a person to a dollar. There's no yardstick by which you can convert directly a person into a dollar. Or I want to add a square foot to a foot. It doesn't make sense. I can't add an area to a length. Right? So that's even more fundamentally sort of screwed up. Okay. So we talked about these, and we said each quantity that we measure, each quantity that we have as a number, say in a simulation model, or for that matter in measured in data that we have that is interfaced to the model, should have a unit and dimension associated with it. So any stock that we point to, we should be able to formulate some unit and some dimension. If you have a set of statistical data, if you're calculating a mean of it, or if you're calculating a standard deviation of it, you should have well-defined units that are the same for all that data, right? You don't want to be taking the average, one thing that's in yards and one thing that's in meter. Just taking the average of the number is not going to give you anything meaningful. You got to have it be uniform dimension. Okay, we talked about this and we said when we associate a quantity with, so this thing we measure, the thing we have in a model, this thing that has a number, we have to give it some clear meaning what its dimension or unit is. How do we express that? Does anyone remember? How do we express its dimension or unit? Well, it's actually a product of different dimensions or units. So the unit of a quantity might be foot. That's a yardstick. Or it could be foot per what? Give me an example. Foot per second. How fast is that dropping, right? Velocity of it. Length per unit time. Or we happen to choose feet for length. And for time we happen to choose second. It could be feet squared per second. How quickly is liquid spreading over the floor? Or cubic feet per second. How quickly does the Saskatchewan River flow, the water through it flow? Cubic feet of water flowing per second. How quickly is it flowing by some, the Broadway Bridge or something like that? That expresses sort of how quickly you might have flow going. Volume per second. Yeah? So we can associate quantities with these so-called productive powers of units. And occasionally we'll even have a fractional power of the unit, the square root of time. You can even have that at times. But all quantities should have a clear dimension. This holds for dynamic modeling and outside. I mean, if you're dealing with statistical data, again, your standard deviation should have a really clear unit with it. Your betas in a regression, if you're doing your statistical analysis, your betas in a regression that you come up with should have a clear unit associated with them. That's important because if you switch units, if you're getting data that's measured in meters instead of in feet, the betas will be different potentially, depending on what their units are. So you need to know what the dimensions are associated with these things if you're going to apply these betas. You can't just assume that the analysis has been done and we'll apply it for this new data which happens to be measured in different units. You'd have to convert the beta. So knowing the dimensions of things matters. It matters when we change units, we change yardsticks. It matters when we change dimensions. But very importantly, it can help us recognize cases where we've made mistakes or help us head off mistakes during our modeling. And again, this holds for statistical modeling, it holds for dynamic modeling. Now, there's certain groups of people who've been doing this for years. Who does this sort of unit? Who does this sort of unit reasoning? Engineers do a tremendous amount. Physicists, people from the natural sciences will often do it. It's one of the things that gets scrutinized if you publish in that area. You write a thesis in that area. You'll have your units carefully checked, and people will look to see things that are nonsensical, where you're adding something that's dimensionally inconsistent. You're adding something that's divided by time to something that has no time dimension. Okay, so we have the opportunity to leverage these things in these models. And the good news is that a lot of packages, including Vensim, do this automatically for us. Not automatically in the sense of assigning dimensions. They don't know what, if I type in a variable name, it doesn't automatically know what its dimensions or units are. After all, I can measure time in any number of different units. But it will check the consistency, okay, of the units. If I give it the units for different things. And that exercise often forces me to think through things in a way that will find errors. But if I assign units, it will check them for me, their consistency. Give me an example of something So we can measure things in all sorts of different ways. But there are some things that just don't cut it, no matter what dimension I use for things. I'll give an example rather than sort of asking you. You can never have a case where a stock and a flow are of the same dimension. Does not make sense. Why doesn't that make sense? Why does that make sense for the stock and a flow to have the same unit? So I say this is in persons and this is in persons. Okay, it is a rate, but okay. So what we do know is that this is an accumulation of these things, right? This is summing up over time, this over time, that's a critical statement, this flow. If I waited for, if this flow is per year, and I waited, well, this flow occurred, and I waited over the course of a year, this will be going up, right? Over the course of that year, 2 years, etc. Yeah? And if I look at the expression for this over time, it's actually an integral of this thing times some small pieces of time. So the unit of this has to be whatever this is times time. Or another way to put it, if you look at the equations for this, the underlying equations, this is a derivative of this. No, it's not the only component of the derivative, but it's one of them. So if this was the only flow into this, this thing, the time, would be this. And so the units of this have to be the units of this divided by time. Okay? So, put it another way, if we changed how we measured time, we measure time in months instead of in years, we'd have to change the value of this flow. We wouldn't have to change the value of the stock. That's the stock at an instant in time. 1,000 people are in this stock. How many people are recovering per unit time? If we went from month to year to measure things, it would change. Right? Where we had 10 people per month, we considered it over a year, it'd be 120 people per year. The flow, how we express this flow would change if we changed the units. Would this change? No. So 1,000 people are in there at this point in time. Right? Okay. So, one illustration. Okay, so we're going to take a look in this short session at how we assign units to things. I'm going to go through a little exercise. Okay? So here we have this little model. It's a simple SIT model. Susceptible, infected, and temporarily recovered. Okay. So, first of all, does anyone want to start helping me with assigning units? What? Can anyone pick out a unit here whose, or a variable here whose unit should be clear?
Oh, the recovery.
Okay, the stocks should be in persons. Now, are there different yardsticks I can measure that? That sort of seems like it's the dimension, sure, people, but it seems like it's also the unit almost. But is there a different unit I could use to measure people?
Unless you're counting susceptible people, infected people.
Okay, so we could actually divide people by their category into different dimensions. That's a more subtle thing I don't want to go into right now, but yes, you could do that. But how else could I count people? I could count them in thousands. I could have one here represent 1,000 people. One way to count people, 0.001 would be one person. Right? I could do that. It just so happens that typically we make use of an assumption as a convenient unit, one person is 1. Okay? I mean, there's really no reason not to here. In an agent-based model, you could, in principle, have an agent-based model where each person being simulated maybe represents 10 people in the whole population. Yeah. Now, that's what something I published in, so we can talk about that. And there's some good reasons for that. Why? Why would you do that? Why in the UN model might you have each person in the simulation be 10 people in Saskatchewan? Saskatchewan has a huge population by many standards, and not as huge as some places. So it has a big population, and the cost of simulating it in an agent-based environment, how does it depend on the population size in the simulation? Rise up also. Yeah. Right. So if you double the population represented in the simulation, the cost actually may more than double in some cases.
As in the cost of the simulation?
Yeah.
Oh, okay.
Yeah. It may take twice as long to run. Computational cost. Whereas in a system dynamics model, if you double the population size here, how will that change the cost? It doesn't at all. Doesn't change the time cost at all. So that's a difference. And it's one of the reasons in a system dynamics model, we'll just say 1 is 1. 1 is 1 person, right? 1 here is 1 person. Okay, so that's persons. How about the unit for time? Where would that be specified? This is something I bet everyone here has seen at one point or another. And they've maybe not given it a second thought. That's actually specified in Vensim. You've actually specified it in your model. I think virtually everyone in this room, with the exception maybe of Simon and Juan Yi, have specified this. Because they haven't yet had the pleasure of the experience of taking my course. So where would you specify that? It's actually a place.
Go in Vensim? No.
Unit checks?
Yeah.
No. Model, settings. Do you remember this thing? You folks have seen that before, I think, right?
Oh, yeah.
This is where you set the initial time count. Have you ever noticed? What is that? That's the unit for time. That's the yardstick by which time is measured. Probably, arguably the most important unit in the whole model. Okay, so does anyone want to give me? So we say these are in persons, yeah. Okay. In fact, person. Okay. How about let's start with something else. How about does anyone recognize something else that might be easy to assign a unit to?
Or sort of the flows.
Okay, the flows. People per unit time. So what that would be person per, given what time is measured in, person per day.
I don't know.
Right? I mean, we just saw it, right? Up here, model, settings, day, right? No? Maybe I should have been more emphatic about it. Okay, so that's person per day, because whatever the stock is per unit time. Person is the stock, time is measured in days. So this has got to be in persons per day. So what are some other low-hanging fruit here? Assign me, so David was saying that these are in persons per day. Oh my gosh!
No. Unit mismatch.
Okay, so
Let the folks from Calgary see that.
I don't know where that came in. Person per month. Ooh. Okay, so this is where you specify units. So every variable has a unit associated with it. This is where you type them in. So we should probably correct this to be person per day. Now, by the way, so a point of reference. You're often going to find yourself, if you're like me, you're often going to find yourself. Is it like persons per day, or but try to make it. My suggestion is convention is to just make it singular. So person, you just always use the singular form.
In Vensim, I remember in the tutorial you said that you could set dates or something.
You could set.
You could set it to say person per day is the same as person per day.
Oh yeah, that's true. You can actually do that.
Somewhere.
That's true. I think that's. We'll show that in just a sec. That's a good point. So this should be in fact person per day. This should be same sort of thing. Okay, let's go up and see where that is. I think it's up here. Oh man, where is it? Variable time axis scaling. No. Okay, we can do that. That's another possibility. Let's see what these are. These are days. That'll be a little bit inconsistent. So where are units defined? That's a good point, Karen. I should know this, but I can't remember. Oh, man. So we got to do this. Vensim. Yeah. Okay, so unit, what are they called? Unit equivalence? Equivalence? Come on. Unit equivalence. Here we go. Yeah. Model settings. Oh yeah. Okay. So model settings, and then there it is. Yeah. So day is day, days. Okay. That's nice. Thank you, Karen. That's. By the way, this is being recorded. I did record successfully that last session. I just didn't upload it. So remind me to upload it. I have to convert it over to MP4 or whatever it is. The MPEG. That's what it is. So you can view it on the site. So I recorded the first part of this dimensional discussion. Well, I can upload it above.
I
Okay.
don't consent.
Sorry?
I don't consent.
Okay, so this is in days. So I'm going to keep it in days. It's a good idea, again, and you need some flexibility. You could have done that. This guy is in days. By the way, oh, look at that. Okay, you'll notice this is actually a really nice feature of Vensim. You put your model, your cursor over it, and if it has a comment, it'll put it, but it will also put the unit, eh? Person per day, yeah. So this should be person per day. This has got to be, this is day, right? So this is, think about the formula. I divided by this, so this has got to be person per day. David, yeah.
Well, no, never mind. That's okay. I actually was just going to ask a question about the numeric value of that recovery delay.
Oh, it was already in days. So, this is based on a whole calculation there, which I'm not going into. So immunity loss delay, and this is person per day and person. Yeah, we may expose that later, but for now, let's focus on this simple structure. Okay, so this is person. So the total population, I plus S plus T. So what does that got to be? What does that got to be?
We're saying person.
Person. Yeah, it's got to be whatever these things are. If it were adding up a flow to these two, that would be nonsensical. Now you're adding something per day to stock, which is people. So you're adding person per day to persons. That doesn't make sense. Among other things, if you were to change your units of measuring time, one would change and the other would. Sorry, it doesn't have a well-defined unit associated with it. Yeah. So total population, so we can do that because these are all equal. How about fractional prevalence? So what is fractional prevalence? Who could tell me what the formula for this is? What does it depend on? Sorry? Yeah, there are the arrows. So it depends on those things. So what's the formula for this?
I over N.
Yeah, I over total population here, or N as David calls it, shorthand. So what's the dimension associated with that?
1.
Okay.
Or
Dimension
actually dimensionless,
is
it's
unit dimension. Okay, now remember we talked about that last time, and I argued just as the term dimensionless is a little bit misleading in the same sense that you wouldn't say something that's of length 0 is lengthless. It has a length, it just happens to be 0. Something that's dimensionless has a dimension where we've said that you can express quantities as the product of powers of dimension. People, or people per unit time, or people per time squared, or what have you. This is something where everything is a 0th power. What does that mean? What does that mean that it's dimensionless? This is really important at a deep level. We're only scratching the surface of it. But what does that mean? That it turns out that's a deep thing if it has unit dimension. What? So it means we don't have to worry about it as much. Why not?
So it's a fraction.
Okay.
It doesn't matter what any set.
That's right. So it doesn't matter what yardstick we
Yeah,
use. If I say this point is halfway through this rod, this point is at the halfway point, 0.5 sort of down the length of the rod. That measurement, it doesn't care. It doesn't have to change. It doesn't have to be updated. If I say, I want to express the length of this stick in meters, in centimeters, in yards,
in decimeters.
A fair thing, or in angstroms. It doesn't matter how I express the length. It doesn't matter the units. The quantity's value will be the same. I can go and change units willy-nilly. I can go up there and change my units of time from month to day. It won't change the value of a quantity like that. Okay. And there are quantities like that. We may have external quantities, which are measures of prevalence in the population, and we don't have to worry about them depending on a unit. So this thing here is dimensionless. How do I specify that in Vensim? There's two ways. Yeah, I can say 1. I can say 1. Actually, there's 3 ways. Let me count them. 1 is 1. I could say 1. Another way is I can say unit dimension. It means the same thing. When you have, yep, and I can also say dimensionless, DMNL. I can pick my way of writing this. Unit. If I leave it blank, that means that I haven't assigned a dimension to it, and it'll complain. It'll complain because it can't do a unit checking on it. This is different than using it blank. Maybe I can help. I can emphasize that. So this quantity, like how far along the rod am I? The fact that it's dimensionless, that has a dimension. It's just it's a dimension which doesn't depend on the units that we select. It's invariant to the units we happen to prefer.
Yeah, halfway is halfway.
Halfway is halfway. Half full is half full. Half empty is half empty.
What about all empty?
All empty is also all empty. No matter what units you have, 0%, 50%. Those. It doesn't matter what units we prefer. Saying half this room is covered by tables. That is something which doesn't matter whether we measure the room in square feet, square meters, square yards, or square light years. So the fact that this is a dimensionless quantity is significant. And it's very different than saying that we're just not going to assign it any dimension. We're just going to leave it blank. There, it's like we don't know what dimension. We know what this dimension is, and it's a very particular dimension. It's dimensionless. It's unit dimension. In the same way, if something is of length if we had a model and we said this quantity, it measured the length of roadways laid down by the city of Calgary, a superhighway, and we said it was 0, that would be very different than not saying anything, leaving it blank. It's, one is very particular value. Okay, this is dimensionless, special type of thing, particularly interesting.
Yeah. So, Nate, and something that always confuses me: unit dimension. Can you I don't get why
it's called a unit.
Yeah, is it unity that is it kind of?
So
is that sort of a mathematical reference? Unit as in being one? No.
No. It is a mathematical reference in that sense. I don't know that I can give it a proper explanation, but let me give one reason. Okay. Okay. So look, folks. And I apologize. I'm going to use the board. Here, I can take advantage of the powers of this tablet PC. And perhaps what we'll do is we'll call up a little side note. Yeah. Okay, so I can write quantities. When I have a quantity that's measured from the external world or that's being simulated, I should be able to write it as the product of powers of dimensions, right? So maybe this is time to the -1 times persons times person. What is that? Could anyone say that in more familiar jargon? Person per time, yeah. By the way, I'm writing as dimensions right now. I mean, maybe I should actually write it just to keep it as nice. Write it as units, right? Unit. Oh, sorry. What am I doing? Write it as day. So persons per day, right? This is the number of people getting infected, maybe the rate at which people are getting infected in the population. Okay, so I can write that quantity that way. Others I might write, person times meter to the -2. So this is persons per square meter. That might be a quantification of how crowded a living situation is, right? Crowding in some area of the city or something like that. Density, in other words, of the population, right? And of course, I could write that just unpacking it a little bit. This is person per meter squared, right? Whoa. Sorry, folks. Person. Oh, what an execrable thing. Okay, so person per meter squared. Yeah. Okay. Okay. What's the thing of unit dimension? Well, look. Imagine that we have these various dimensions in our system, various units. Something of unit dimension, like a fraction. Check it out. Watch this. So fraction in this room covered by tables. Eh? How much is measured by tables? I can measure it, right? Oh, look, these are square feet on the ground here. I could count them up, right? And I could count the amount covered by tables. 100. It's a lot more than that, but well, maybe not. Square feet. Maybe I'll write it as, oh my goodness, feet squared, right? Feet squared divided by the entire area of the room, whatever it is, 400 feet squared. What happens to the units here?
Well, I know what happened here. They cancel out.
That's right. And how else could I measure this? And this is getting to the kicker. This is getting to, what's that? It's a quarter of the room. I could write it as that, right?
Yeah.
Okay.
Yeah.
So in general, I could add without malice or harm. I could also add in here. This is going to be weird, but I could add in that, right?
Yeah.
Person 0 power. It doesn't. It's not depending on that. And I could add in, for that matter, I could add in day to the 0 power, right? So when you have a quantity that has, let me ask this, mathematically, if you have a quantity that has like 2 to the 0 times 5 to the 0 times 7 to the 0 or something like that,
Yeah.
what does this evaluate to? What is 2 to the 0?
1.
What is it? What is this to the 0?
1.
What is that to the 0?
And it's all
By the same token,
yeah.
each of these is sort of unit dimension. Any multiplication of them is unit dimension. So I think that's what kind of why it's called unit dimension, sort of by extension, dimension.
That makes. I'm sorry.
The
that
one makes sense.
Yeah.
that you
Wait, the
wrote
one
the
makes
one.
sense, but unit dimension, like
Yeah.
the actual like name of unit dimension makes
Yeah.
no sense to me.
Okay, 1 is sometimes called a unit. It's called unit.
And that's what I asked. I said so
Yeah.
mathematically. So yes
Oh,
is
okay.
right. So yes is the answer to my question.
Oh yeah, and I said yes, but I thought I'd give a more complete explanation.
Okay. Okay.
So yes, I said yes, it's by sort of analogy with mathematics. So this is called, a 1 in mathematics is called a unit. It's
Well,
called
you're right. So R naught approaches
unit
unity,
value.
right?
Approaches
It's-
unity,
It's just one.
its approach is 1.
Yeah. Okay.
Yeah.
Yeah.
This is-
Okay.
So unity.
Yeah. And that's okay. That's what I was asking. 'Cause that's what I thought it meant. Okay.
Yep.
So yes.
So this is sort of, in a dimensional sense, this is unity.
Yeah. Okay.
Yeah.
Okay. Cool. Yeah.
Yeah.
That makes a lot of sense.
Okay, so we're getting that then. Any questions further though on that issue of dimensionless quantities? By the way, the deep thing here, for anyone who wants to ponder it, I'd be glad to talk more offline. And it's something really that has profound implications when it comes to other sorts of modeling and even agent-based modeling. Is that the world doesn't care about our choice of units. How the world operates, it goes on doing its thing, regardless of how we measure things. We could measure the world, and we can make up any units we want, any yardsticks we want, but the physical processes operate just the same. The trees sway just the same. The infections spread just the same. And what that means is any model that accurately captures how the world's sort of governing processes, the process by which these things spread, should be able to be defined in terms of dimensionless quantities only. Should be able to be defined ultimately in terms of quantities, could be expressed dimensionlessly. And so if you work with physicists, as I've had the pleasure of doing,
So not unitless, but dimensionless.
well, same thing.
Well, okay.
Same
Well,
thing.
yeah, but it's. I mean, they are kind of two different. Well, okay. I shouldn't say two different things, but there is a distinction, which I guess I'm just trying to keep in my head.
I think all things that are dimensionless are unitless. And vice
Okay.
versa.
Okay. Okay. So it's
But
like
again, it's an abusive term.
Oh, okay, okay.
In the same sense, lengthless is
Gotcha.
kind of abusive. Yeah. So the world actually operates using dimensionless quantities. In fact, any model that's dimensionally consistent should be able to be reformed in a dimensionless way. But that's not something anyone here should have to do. It's a fact that's interesting. It turns out it allows for some scaling arguments about how models should behave as you double parameter values or what have you. It gives some sense to how a model will behave for different values of parameters, given what you know about it for certain values of parameters. Okay, but let's continue sort of our assignment of dimensions. So we've gone through a lot of these. Okay, now this starts to get interesting. We'll start with some of the more interesting ones. Mean infectious contacts per susceptible. Okay, so this is the fractional prevalence. Well, okay, let's start with this one. Mean contacts per capita. How many people does each person contact per unit time? Right? This is, remember C, for those of you who have taken my class? Remember beta C that's used in the transmission equation? C measures how many people each person is coming in, each susceptible person is coming into contact with per unit time? So what would the units of that be? Let me ask this. This is one way to think about it. If I were to change the unit of time, if you were to say, well, let's measure this in months instead. So I measure it in months. Would I have to change the value of C? How many people per unit time someone comes into contact with? If I were to measure time in months instead of days, if I were to measure time in months rather than days, would that change the value of C numerically? So if I quantified this person, I start with days, this person comes into contact with 3 people per day. If I were to change it to months, would that change how many people they come into per unit time? Yes. Yes. They come into a lot more people, contact with a lot more people in a month. Okay? Okay. Okay. So we know that this has to depend on time. Has to depend on time as invention. Value's going to be different. Does it depend on how we measure people? This is contacts per capita. It's person per person. Number of contacts measured as persons per person in the population per unit of time.
And that won't matter because you could be people or thousands of people or hundreds of thousands.
Right. You could measure both the denominator and the numerator.
We'll cancel out.
So actually this here is actually person per day. Okay. So what does this guy have to be? If that's fractional prevalence times contacts per capita, what does the unit of this guy have to be? By the way, that's wrong. But what's the unit of it? Same as me, because this guy is dimensionless. This guy unit dimension, and so multiplying it by that's just it doesn't change the dimension of this at all. And so this is going to be the same as mean contacts per capita, which was
1 over Fraggles.
So yeah, it would also be person per person. So why person per person? This is the number of people they come into contact with per person in the population per day, right?
Well, you actually could even write person per person times per person per day.
I could. Yeah. It just helps to think it through sometimes. Okay, how about the per infected contact infection rate? How about the infection rate? Beta. This is the probability a given contact between a susceptible and infected will transmit between this discordant pair. What's the dimension associated with that?
With the probability?
Yeah.
It's dimensionless.
It's dimensionless. Another way to think about it is how many persons get infected per infective contact. Per person that's reached by an infected person. But yeah, probabilities in general are dimensionless, have unit dimension. Okay, this guy here then, yeah.
It depends on the duration of infectiousness of that individual, right?
It will at any given point in time. So the duration of illness is going to affect how many people are ultimately affected. But it's going to affect R naught. How many people get infected by them over the course of their illness, or R star more generally, the effective reproductive number. But if you ask for a given contact between an infective person and a susceptible person, on the other hand, what's the chance that you'll transmit? It should always be the same, and it doesn't matter how you measure persons.
Yeah. Although is beta always represented as a probability? Not all the time, right?
Not all the time, no. Sometimes they're combined together to
right.
Yeah.
Right. Or I'm thinking kind of like from say some of the within-host models. Beta isn't necessarily a probability.
Right.
Like,
Yeah, that's true.
Right, like,
Yeah.
It's
Yeah.
beta C, basically?
well, yeah, I think so. Like, I'm not really sure because it's often like 1 over. Actually, I'm blanking on the units, but beta is not always a probability.
It's not always. It's just in these
yeah.
models, and how it's used here.
Yeah.
So,
Yeah.
So look, per susceptible incidence rate. Now we have a per infected contact infection rate times this thing. This thing is dimensionless. This thing here has got to be person per person per day. That's what this one was. It's the unit associated with that guy there. And I'm going to have to finish up here in just a minute for another meeting here, but that's person per day. And that will give us then, when we multiply per this, okay, so this is sort of where the chickens come home to roost. So this guy here, we know that if this stock is in persons, this has got to have units person per day, right? What is the formula for this guy? Yeah, this is actually the force of infection. Yeah. And so whatever units that are, if you multiply them, it has to give the units for this. The units of this are what? Units of this are units of new infections are persons per day. Yeah. Of the entire flow.
Well, the flow is person per day.
Right.
But the persons have to.
That's right. So this guy here, to combine with this to yield the dimension of the flow, has to be 1 over day. And that's in fact what we have, right? It's person per day. These cancel, just 1 over day. Yeah. So that was the most complicated thing. These things here are going to be in days. We can look at a more sophisticated model another time, but that's an example of labeling the units. Now, how would I do a unit check? I don't have time to go through it now, and I haven't labeled all of them here. But you go to model unit check, and if your model is okay, what will it say, David?
Units A-okay.
That's right. That's right. And so I'll just show that by showing a simple model where everything is labeled. So this is population, and this is births, right? Births, and this is deaths, and this is birth rate, and this is death rate, and here we go, and do that. Okay, so let's go quick now. So give me the units.
People.
Okay, it's starting at 100. This is in, let's just say person. It's my preferred way of labeling it. Okay, we're going to leave those for last. How about this one? What has it got to be?
People or person per year. Or per time, I guess, whatever.
Okay, so births is going to be birth rate times population. I'm filling in this, but it's person per whatever it is. Let's make it year, okay? Because often birth rates are in year. Yeah, I can't remember what's default, if it's months or year. No, it's months. So so let's choose year just because birth rates and death rates are often in years. Okay, this is death rate times population is the formula, right? And then we've got person per year as the unit. And then we have death rate, I'm going to make it 0.01, and the birth rate is 0.02. And we should be able to do, oh, I forgot to specify the units. What are the units of these guys? What do they got to be?
1 over year.
1 over year, because when they multiply by population, the resulting unit has got to be person per year, right? 1 over year. And this has got to be 1 over year.
Years from last one.
Yeah, yeah, that's right. And we do model unit check. No, units are A-okay. And if I had a problem here, if I said that this is
Just say 1. Yeah.
1, and I tried to do it, and I'd say no, and it says errors in the units. In this equation, the birth rate is 1, population is given as person, but births is given, and you told me that it's person per year, but this doesn't drive. Right-hand and left-hand units do not match. This guy, for births, the units for birth don't match the units for the right-hand side of this thing here. So it says births is units persons per year. Birth rate times population has units person. So that?
So does the model, sorry, did you say, like if you had them in your model here,
Yep.
and your model setting is set at months,
Yep.
is that still okay? And it's just,
No.
you have to make sure that both things are right?
Well, right, and the problem with that, it's a very good question. Let's see what would happen. So we make this 1 over a year, and we set the model settings to be month, like we had it. It turns out that for reasons that may not be totally clear at first glance, that will give problem, should give problem. Yeah.
Oh, yeah.
Yeah. And the problem is here.
Yeah.
Basically, when you integrate this, what is an integration? It's just the sum of births minus deaths as a quantity, all times some small units of time, deltas of time. It's just summing them up. This thing times time. Sums it for that little bit of time. Next thing, that minus thing times some delta of time. Sums it up. Same thing for next, right? Just keeps on doing that. Now, this thing here has units what? Well, it's births, which is persons per year, minus deaths, which is persons per year, as we've told it. And then it multiplies that times that small unit of time. What's that unit of time measured in? It's measured in whatever we told it up in this model settings, which is months. So it's going to be adding these things up of person per year times months, totaling them up. And that's what it's gets out. But we told it that the stock had units person. So it gets upset. Yeah? So we would need to provide some sort of converter. In other words, we need to convert these to be persons per month.
So the model settings is the integration.
It sets time, the unit of time across the entire model. And we want to use, this is important. This is not a sort of minor issue. We actually want to be very careful we're using consistent units across time units. Now look, that doesn't mean you can't use somewhere in the model something that's per month, but if you're gonna combine it with other things, you gotta convert it. You don't want to be converting this number of vaccines per month to this number of vaccinations per year or per day. You don't want to be adding them together or something like that. So you're going to need to convert, and maybe even next time I'll show you a little example we'll walk through where you have to worry about that. You have to be thinking about that issue, because you prefer to say something, say monthly salary, you prefer to say salaries per month, but other things like birth rate or life years lived, you want to say in years. And if you're going to combine them, that's fine. You just got to combine them in a principled way. You got to combine them in a consistent way. Does that make sense?
Do you think
by translate, what do I mean? I mean actually convert. Just like you want to add this 1 foot to this 1 yard, you got to convert yards to feet.
Or feet to yards.
Or feet to yards. So if I want to do yards to feet, it becomes 3 feet, and then I can add it together. No problem. But if I were to just add it as 1 and 1, then I'm causing big problems because it's 2 of something meaningless. The computer will do it for you, but it's meaningless. And we want models, at least in this group, which are meaningful. So we want to be careful about our units. And good exercise will be labeling all models with some units. Good. Is that okay for a starter for how you use the tools for Vensim? And I will prod me if I don't post this shortly. I just got to convert these all. It actually takes a little bit of time.